For this study, I worked in Seward Park with the organization Friends of Seward Park, analyzing Western hemlock health. Seward Park is the largest forest within the bounds of Seattle. It's a very popular spot for people to go and walk around. Very importantly, it's an urban forest, so it has significant effects serving as a carbon sink, mitigating pollution by removing particulate matter from the air, acting as a habitat for wildlife, and providing recreation for nearby residents. In the past few years, an increasing number of sickly western hemlocks in the northern area of the park has been observed, but no obvious decline has hit the southern area. We conducted this survey to see if there was actually a significant difference in health between the northern and southern areas of the forest. Establishing this would have intriguing implications regarding the main factor causing tree death. To start off, we created two rather subjective polygons on the map, mainly based on where we saw the most hemlocks, and those served as our two initial study areas. Then we surveyed every western hemlock that we could find within those two areas. There were four of us surveying the trees, which sped up the process. We collected summary statistics for each tree. So the protocol was to get the GPS coordinates from Google Maps, tape the tree and write a number on it so that we couldn't count one tree multiple times, measure the DBH, diameter at breast height, which correlates strongly with age because usually the larger trees tend to be the older ones, and measuring the slope and aspect of the surrounding ground. So that was to see if trees growing on steep slopes were sicklier or vice versa. Then, most importantly, we rated the tree's health. So we did that on a scale from 0 to 3, where very sick trees got ratings closer to 0, and healthy trees were closer to 3. Each third of the tree received a rating, then we averaged those numbers for the tree's overall rating. This was essentially based on how green the tree was, how many healthy needles it had. It wasn't quite that simple because many trees were in the process of shedding branches and were less green than the prototypical tree that would receive a rating of 3. But with time, it was easy to differentiate between sick trees and healthy trees that were just shedding branches. We ended up with over 700 trees surveyed by mid-March. Around that time, we also redefined our two study sites based on density, which basically split the mapped hemlocks into the healthy zone 1 near the south and unhealthy zone 2 near the north. And this is spoiling the result that we did find a significant difference in health between the zones, which you can see in figure 5, the map. The healthy zone ended up being a very oblong, large range, and the unhealthy zone to the north was more small and circular. In Zone 1 had an average health rating of 1.93, while Zone 2 had a rating of just 0.74. We also had 134 trees outside of either zone, and they averaged 1.45 health. As it turned out, as you can see in figure 6, diameter and health were not correlated at all, so this contradicts the natural senescence theory that is widespread in forest ecology and says that widespread tree death is seen in Seward Park tends to be ascribable to age alone. So something else is happening here. Something else is contributing to the decline in hemlock health. We figured out that geology and climate differences between the two areas can be ruled out as factors because sections of Zone 1 and 2 have the same underlying bedrock, and there's no difference in temperature between the zones. Even though heat waves could exacerbate the tree decline in the north, hitting the already weaker ones. So the most likely factor we speculated upon was the presence of a pathogen, and there will be DNA sequencing in the summer to see if one could be identified. And if there is a pathogen that's found, it's unclear what move would be made because a pathogen could mean anything from insects to fungal rot to very small bacteria. And there are forms of chemical control or biocontrol that usually tend to be invested in by timber companies for Western hemlock, since trees commonly used for trim work on buildings. But it's unclear whether such measures would be taken in a forest that has no logging, and it's also not one solution fits all, because biocontrol is only for specific types of pathogens. And so the hopeful outcome is that the die-off is contained to one area, but it does appear to be spreading based on what's happening recently. And if the trees continue to die out, there's a whole host of negative side effects. People wouldn't like walking around the forest quite as much. Less carbon capture taking place, air quality will take a hit, and heat waves will be worse because forests can help offset them. So lots of benefits for urban forests. Even if the hemlocks of Seward Park keep dying out, the study does provide a jumping off point for further research regarding the trees. There's a general lack of literature about western hemlocks, and it'd be useful to have more. So the first part of any solution is to identify that the problem exists, and that is what we did here. So that is essentially it. Thank you.